Hello, 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 everybody, and welcome back. Welcome back. We're looking at question 4 now on the Euclid paper, the grade 12 scholarship level paper from 2006. So question 4, if we're just on the page, it looks like, oh, it's just a quick light bulb, but this A here indicates that, yep, there's going to be a B, and there it is, and the B will be written. Okay. We'll focus on our light bulb question here. In the diagram, the rectangle is divided into 9 smaller rectangles. The areas of 5 of these rectangles are given. Determine the area of the rectangle labeled R. Okay. So this question can, I've seen a question like this, I think, on a past Fermat or Pascal or something like that. It was one of the multiple choice ones, not from this year, I don't think. But I've seen questions like this before, and they give you some of the areas. There's sort of 2 approaches I have to this type of question. Either way, we're going to need to copy down our rectangles. And it doesn't actually matter if they look proper. So there's the R we want. I think it was 1, 2, 3, I think a 5 and a 10. I'm not sure. I only got a quick glance at it. Not 2, 1. But, not bad for only taking a gander at it. Alright, so we got 2, 1. Alright, so there's 2 ways I can think to go about doing this one. One is, we want x and y. We want to know what x times y is. So what we can do is we can start working backwards. Well, x times whatever this is has got to be equal to 10, so this is 10 over x. Okay, and these are all rectangles, so this length over here is 10 over x. Well, 10 over x times something has got to be equal to 5. So this is going to be x over 2, and then we carry the x over 2 up here, and that sort of stuff. And, we can start from this y here. This is going to be 2 over y. And then this is going to be y over 2. And then I know x over 2 times y over 2 has to be equal to 3. So x times y has got to be multiplied by 4 there. We get 12, so area of R is going to be 12. That's a fine way to do it. Another way you can do it is, you'll notice these numbers really don't matter here. This is a quicker, sort of more numbery way to do it. It can fail in some ways, but not for a question as simple as this. So you can just say something like, well, this looks kind of long, so it's a 5, and this is a 2. Okay, well, if this is a 2 here, so I'm doing the exact same thing, but I've got an actual number kicking around. And I can only go the one direction, so I will work all the way down, and then I will get this number here, and it'll have to be 12 over 5, but we'll see that in a moment. But 12 over 5 times 5, and then we'll get 12 exactly. Now this can fail if there were multiple ways if there was another way we could go through this. We might get, oh, this has to be 3 somehow, and then, oh, 3 times 2, we chose the wrong number for the 5 there. It's not going to happen in this case, so don't worry about it, but this will be 5 over 2. So this has to be 5 over 2, and then they have to multiply to be 3. So this is going to be 6 over 5. This will have to be 5 over 6, and they have to multiply to 2, so this is going to be 12 over 5, and R is going to be 12. So either way we can do it, stick an actual number in there and see what happens, or if you want to be a bit more cautious, but, slightly more annoying to keep all the way through, throw in some variables. You don't even have to have that y, you can just bring that x along, and you will get 12 over x in the end. But, yeah, that's how we do A. Very quick to do. Okay, B part here. So this is the one where we actually have to be careful. We have to actually explain and write up what we're doing. In the diagram, the circle with center 1, 1 passes through the origin and intersects the y-axis at A and the x-axis at 2, 0. Kind of wish they had the letters different because I usually expect the y-intercept to be a B, but it doesn't really matter. Determine with justification the coordinates of A and the area of the part of the circle that lies in the first quadrant. So we got 2 things. We need to figure out A. the coordinates of A, and then we have to figure out some areas here. So I think the easiest thing would probably figure out A first. That makes the most sense. What can we do? Well, it's the grade 12 contest. I suppose we could figure out the equation for the circle. We know its center. So just draw a very quick sketch of it. It goes through like this. And we know it passes through the origin. And we know its center is going to be 1, 1. So that information is enough to actually give us the radius, which would give us the full equation. And then A is going to be when we have the x-coordinate 0 and not the y-coordinate 0 as well. So C is the center. So for radius r, our circle has equation x minus 1 squared plus y minus 1 squared. You just subtract off the corresponding coordinate from the center is equal to r squared. 0, 0 is on the circle. So that means it satisfies the equation. So 0 minus 1 squared plus 0 minus 1 squared is equal to r squared. But this is 1 plus 1, 2 is equal to r squared. R is equal to root 2. R squared is equal to 2. So now I know the equation of my circle. Circle has equation x minus 1 squared plus y minus 1 squared is equal to 2. And if we wanted to, we could double check. We know what the coordinates for B are. It's 2, 0. 2 minus 1 is 1, squared is 1. 0 minus 1 is 1, squared is 1. And that also makes me think that A is going to have coordinates 0, 2. A has x coordinate equal to 0 and y coordinate not equal to 0 because it can't be the origin. So 0 minus 1 squared plus the y minus 1 squared is equal to 2. Then that'll rearrange to y minus 1 squared is equal to 2 minus 1, which is 1. So y minus 1 is plus or minus 1. Y is 0 or 2. So A has coordinates 0, 2. Just like B had 2, 0. Alright, so that's sort of helpful. Now we want to get the area, don't we? The area which lies within the first quadrant. I've got my A up here, I've got my B here. My center C is 1, 1. So not so bad. Now, we could figure out the area of this little bit and the area of this little bit and subtract off from the whole area. That's certainly possible because we do have O and A, so we could figure out this angle and subtract off a triangle. And it's possible. It certainly is possible, and if that's the way you did it, that's fine. But you're making more work for yourself. What I'm going to do is I'm going to use the fact that A and B are both on the X and Y axes, and there's a little circle geometry can help us out here. So it's certainly possible to figure out these, subtract them off, and that's originally what I thought I was going to have to do when I read that I have to get the area. But notice that AB gives us O here, and we've got a right angle. The only way you can get a right angle from a triangle that's got a point on the circle is if AB is a diameter. So notice AOB is a right triangle. So that tells me, and this is just some basic circle geometry that you sort of can just know, and it's fine to state AB is a I don't know why I put a G there. AB is a diameter. So what does that tell me? Well, if it's a diameter, then this purple area here is half of the circle. And then we have this blue area, which is the area of a 2 by 2 circle. Or not 2 by 2 circle, 2 by 2 triangle. So the area in the first quadrant, and if you don't want to explain this in detail, have a picture with some colors here, or at least some arrows pointing out the different areas, equals area of a semicircle plus 1/2 base times height. And I would write it like this and then now fill it in. We know the radius of the circle is √2. So what's the area of a semicircle? Well, it's half of the pi r squared. And this is a half of 2 times 2. So r squared is 2, so we have 1/2 pi times 2 plus 1/2 2 times 2. Whole lot of canceling going on, and we get pi plus 2 as our final answer. And that's the area that is present in the first quadrant. And you might want a little therefore statement saying, you know, the area of the circle that lies in the first quadrant is pi plus 2. But I'm just going to leave it in my boxed answer. And yeah, that wraps up question 4. 2 very disjoint questions, I would say. I mean, roughly they have the word area in them, but that's about it. And you find as we move further on into the contest that the two-parters tend to have a little bit more to do with each other. And so on. It's not an ironclad rule, but I find that will happen more and more. The earlier questions are just sort of two questions stuck together because they weren't hard enough on their own. But yeah, there's question 4, and we look forward to question number 5, or at least I'm looking forward to question number 5. Feel free to join me for that one. Skip ahead to 6, 7, 8, whichever one you want. But whatever video you do end up watching, I will see you guys there. Thank you for watching, and have yourselves a wonderful day.